Kubernetes security learning series point of view. 13th topic is security context for pod or container. So I am in training.linuxfoundation.org. Under this, set up appropriate OS level security domains using PSP OPA that we have seen in the previous sessions. If anybody have not seen, please refer the video. And now the final is security context. So what exactly the security context for pod or container? So let's try to understand the basic. If you take any host, we are talking with respect to Kubernetes, right? So Kubernetes host will have a kernel space. Yes, kernel space is on top of a hardware. Then there will be a user space. Whenever you deploy application is nothing but which is as a pod you will deploy, right? So this pod has some logic, some application, and you deploy, and it is making some system calls which is interacting with the kernel and which is ultimately using internally hardware and all. So how this pod will call SysCalls? By using a security context. Unless this pod has some security context, it won't be interacting with the kernel and doing something. So this everything is based on what? Security context. Unless you have a gate pass, you won't be able to perform the kernel. I hope you understand. Next is security context for the pod. Now in the previous slide, what is security context? It's a context where pod will use as a in hand, right? Now security context for pod and container. What exactly it will do? As the name suggests, security context. So for pod or container, if you take a pod is nothing but one or more containers, right? Pod will have a one or more container. Whereas pod specific security privileges and access control settings, the security context will define. That means privilege and security access control setting. Here, this pod has a privilege to invoke some admin kernel command. This pod has a access control settings as a security context, then only it will be able to make all these calls. That's what the security context. Maybe you can say, what are the security context examples? For example, permission to access an object. So in the previous slide, say in the kernel space there is one object, system object. So if pod wanted to access, yes, that is by using a security context. So, and second is security enhanced Linux, we will call as a seLinux, which is object assigned or security labels. So that's what the security base of. Then another one is you can run this pod as a privileged or unprivileged. That also means, let's say this pod has two containers. One pod you can run as a privileged, another pod you can run as a unprivileged. So, and Linux capabilities, all Linux specific capabilities, and app armor profile that we have seen in the previous video, and SecComp filter. So app armor is basically access related, SecComp is specific to the system calls restriction. So these two, maybe you can ask these two what it is. App armor is restricting the access to the pod. SecComp is filtering the SysCalls. You can filter out what are the things, but all are where it is as a security context. And allow privilege escalation. So this is also one of the feature where you can escalate. So if this container has a privilege escalation, right? Privilege escalation means what? Say somebody made me a boss. I can hire 100 people and just collapse the company, something like that, right? That's a kind of a privilege escalation. And another is a read-only root file system. Basically, this pod has a containers. These containers will be accessing a root file systems, which is mounted in the pod. That we will see. Now, this is a pod. And pod will have a one or more containers. As we know, one container, say pod I am running as a user as 1000, as a Linux user ID 1000. But in the container level, if I don't specify, these two containers will run as 1000 user. But if I override as a 2000 user, this will run as 2000, and what about the container to run as 1000? So that means this is a root, this is a child level. So child level, it will inherit there. That's what how the container security context will work. Then here say if I specify 3000, then this container will run as a 3000, this container run as a 2000. Then there won't be any problem because these users are having a limited permission. Something like that you can set up your containers. And an example, allow privilege escalation, read only root file system, run as a group. So you can just configure like a containers as like a you need. You can set all these things. Ultimately here pod is nothing but multiple containers. So whenever you do something, anything related to the access and security related, everything will goes under the security context. Next is security context at pod level. So this is the YAML definition file, and by the way, and I have taken this from the this Kubernetes documentation, and if you expand a 4.1, then it's a first topic security context, and if you scroll down a bit, there is a security context, and this is a documentation link. In fact, you can go to the Kubernetes documentation, just search for a security context, it will be there, and everything it's here. This is what the sample YAML file which I am trying to show here. Right. So basically here you are creating a pod as usual. Here basically pod level there is a security context. Pod level you are set as a user 1000, group as a 3000, FS group as a 200. This is a Linux group, Linux user, Linux. Then container, here in this pod my only one container which is a busy box, it has a this name. And what is the context I set it here? Allow privilege escalation is a false I made, but I did not set any user or here because everything it will be inherited from here. That's what the. So if you set pod level and container, you define a multiple 1 2 3 multi container, all will inherit unless you specify. So I'll go to the next slide. This is the second example. Basically here pod running as a 1000, that's a rule I defined, but I have a one container, that container level I want to use as a 2000, but I will put another container, I will run as a 3000. Yes, it's possible. If you don't specify, it will inherit from the parent. That's simple logic we need to keep. Then yeah, allow privilege escalation. This is basically if you wanted to escalate the privileges of this guy, then you can set it to true. This is a security setting, but better do not. And if you wanted to know about this particular meaning, go to the console. I'm in a 2-node Kubernetes cluster. One is a master and one is a worker node. So kubectl explain I want a pod under spec, spec spec dot, I want to know security context dot security context. And if I hit here, right, pod security context, this is the what the description, and under that pod level these are the settings you can do. And here I wanted to get a container level security context, allow privilege escalation, right? So same thing, pod dot containers dot security context dot allow privilege escalation, P and E capital. So let's first run this and copy the allow privilege escalation. Yes, it will be there here, allow privilege escalation. And yes, this is the what the, right, this is the what the definition, and you can see what is the case sensitive and all. You can just refer copy, and if you wanted to say dot, I will paste, right, that's it. It will give me the my definition. So this way you can explore about this particular documentation if you don't know on and other one is basically capabilities for the container. Now we set, right, say for example I have a one container and I wanted to set some capabilities. Say I have a pod and in the two containers I have, let's consider here this example, one container, and let's consider another container, and one of the container requires some capabilities. Not as a root user, I don't want to run as a user, but whereas I wanted to set very few, only change the system time and network admin, these two capabilities I want, that's it, because my business is require this capabilities. In that case you set capabilities under add. How to what is its meaning? Go to this bot security context capabilities, capabilities, right, see here what you can do, add drop while running a container. Yeah, just is a self descriptive, just you can read that. So you can add, you can drop. If you wanted to remove, you can drop, something like that you can set it. So that's how the, and yeah, and also for container level you can set a SecComp profile as well. So here I set the basically Linux capabilities, right? So if you look at here in this one, as I wanted to set a SecComp profile, under security context set SecComp profile and type, maybe you want to use a SecComp as a default, or you wanted to use a local profile. And I have made a video on the SecComp profile. If anybody want to know more about the SecComp with the demo, please refer my video, right? So this is how. And if I wanted to use the SELinux, then use security context. Everywhere is there, the SELinux options level, and you put that level. So you need to know bit background about the security context. And how to know its documentation, just go there, right? Here I wanted to know, right, container level. So here, go there, right, security context, container level, enter. Here allow privilege, we just now we seen, capabilities we just now seen, right? And SELinux options, which is this guy, and SecComp profile, yes, you can set a SecComp profile, right? So that's how you can achieve the whatever the security setting under the, if you wanted to run as a non-root user, or you wanted to like a privilege, or you wanted to like you, so you need to read the documentation and go deeper, how your business needs for the pod. Now the final part is demo. So I'm in a 2-node Kubernetes cluster, and kubectl get pods. I don't have any pods, so I will be taking a documentation as a reference for the demo. So if you look at here, this is a pod, set security context for the pod, right? Here basically pod level security context is set this 3, and then container is this container, busybox container, and it's volume mounted, and privilege escalation false. So I will try to apply this file, and I will try to test. So now the number 1 kubectl apply -f, and this is the file, right? And a pod is created. What is a pod name? Here I mentioned security context to demo, simple. So kubectl get pod, right? Yeah, pod is running. Now I wanted to go inside the pod. So basically what I have done, what is the example is here, run as a user 1000, group is 3000, fs group is 2000, and this is a, so kubectl execute in interactive mode, security context is domain is a pod name, and -, and shell, begin the shell. So now I am inside the this pod. So if I say ps aux, right? So what is the PID is running as a user 1000. So in this Linux system there are 3 processes are running inside. So all are running as a 1000. Why? Because I have set in this configuration as a 1000. Now how to test this group 3000 and fs group 2000? Yes. So if you look at here, there is a something is mounted here, data/demo. So right. So I will say cd, first of all do ls, right? Data is there. So cd data ls-l, right? There is a demo folder, and I have permissions cd demo, right? I am in inside the data demo ls-l, nothing is there. So what I will do is I will try to create a file. So echo hello to one file called test. Now ls-l, oh sorry, clear, ls-l. So what is this 1000 is a user, what is this 2000 is a group. So that's what all the commands are here, so need not to worry. Now I wanted to see, say if I specify id. So when I enter id, what is the user id of this container? 1000. What is the gid? Is a 3000. This gid is nothing but this guy, run as a group id. And what is the groups? fs group is a 2000. So that's what the end of the demo, that exit. So kubectl describe pod if I say, right? So basically this busybox pod is using the security context what I defined. Now the second example point of view, set security context for container. So if you look at this example, this is a pod name, and the pod level it set it as a run as a user 1000, but whereas container level it set as a 2000. So if we don't set as a 2000, what happened? The 1000 will inherit here. So, and I'll copy here. So what I will do is I will create a vi security context demo2. Say I will see the demo2.yaml and I will open and I will paste it here. So now what I will do is first container is has a 2000, pod level 1000. So what I will do is I will create another container which is this one, busybox container, right? So for example here, right, right, so here and here if I go and paste it here, right? So here what I will do is container name I will just mention as a busybox, right? And here what I am doing is I did not specify anything, so I'll just copy this and paste. So and I will remove this, right? Yeah, so now, so just we will see in the Visual Studio Code, so that we'll see in a better way. Yeah, so in the demo2 what I am doing is here, right, pod level is 1000, first container is basically using a 2000 user, and second container which is a busybox which is not using any user. So this will inherit which ID? This ID. So let's prove that. So now kubectl apply -f, what is this? demo2 -yaml. So demo2.yaml I applied. So kubectl get pod -w. Oops, sorry, my bad. Yeah, this is demo2. It has a 2 container, out of 2 it's running. That's cool. Now kubectl get pod, now it's running. Now I will go kubectl execute, right, and in interactive mode I will take this and I wanted to go inside the first container. What is this first container? This is a copy this name -c and container name, and what I wanted to open shell. So I open a shell. So what is this first container is running as a user 2000. So I just simply ps aux. What is a user is running? 2000. As simple as that. So just simple exit. What I will do is I will go inside this pod, but I will go inside the busybox. So -c means container, because busybox sh. So now I am inside the second container. So here ps aux. Now what user is taking 1000, but whereas for first container 2000. How it is? Because this value is inherited over here, because here I haven't overwritten. That's what the second example is all about, right? So now let's go to the third example. So third example, what it is saying is configure a volume permission and set security context for the container. I think this is done. Set capabilities for the container. So basically capabilities. So what it means is, if you look at this pod, just simply one container, nothing else. So what I will do, I will try to delete this, delete pod, because it will take some memory and all. I don't want that. And then I will try to delete the first one also, because I don't want I want this is very small cluster. Now nothing is there. Now I will try to apply this third one, right? kubectl apply -f and paste. Done. Now created kubectl get pod. Now security context pod 3 running is a simple pod, right? If I go inside, then this is a command, then I will go inside, right? ps aux, right? It's simple running as a root user, right? And basically if you look at here, and it's running as a root user, process ID is a 1, and I wanted to know this particular process is, what is the status of this process and what are the capabilities. So for that you need, there is a in Linux cd.proc / this one and -1. What exactly it is it is a process file where it will show each process specific the status and what are the capabilities. When you shut down the machine, this file won't be there. So that's what the, say if I hit here, then I'll go inside and cat, there is a status file. This is the status. Now I will open a new duplicate tab right here. If you look at the capabilities, right, documentation again, cap PRM, cap EFF, cap PRM, EFF, right, 425 FB, this is the one. These are the Linux capabilities. Now I will go here. Then now I will, there is another one where the same pod, same as the third one is this, right, same as the third pod, but capability set it as change the system time and network admin. So let's try to apply that. So I will kubectl apply -f. Oops, sorry. Right now it's getting applied. Maybe it will take a few seconds. Yes, it's created. Now kubectl get pod, right? Now demo 4 is also running. Demo 4 is nothing but this one. Now what I will do is I will go inside the fourth pod, right? Now kubectl execute in interactive mode, and the fourth one, and then -sh, right? I'm inside the fourth pod. What after the fourth pod? I will do the same thing, which is ps-aux. I will see, yes, it's running as a root user, and I will go to the cd -proc, and I out of proc it's a 1 I am in, right, pwd, right. Now cat status, if you look at here, right, what is the Linux? Cat PRM and cat EFF, right? So if you look at this cat PRM, cat EFF, this is pod is basically fourth one is running as a some capabilities. Here the ID 435 FB, but whereas the last one, which I haven't set the capabilities, 425 FB. So there is a difference. That's what the capabilities, and if you can decode and more dig into the what is this value and all, you will come to know. But the main idea is basically when you set it into the security context, it will takes consideration of your pod, and so that you will achieve ultimately this particular security for the pod. That's what the, and if you want, you can set the SecComp and all. That's it. These are the examples they given, and yeah, that's it for the this demo point of view. And let me know in your feedback as a comments. Thank you. Bye bye.